Hey everyone, welcome back. Today we're tackling a neat little problem from Leetcode, number 2264, largest three same-digit number in string. It sounds a bit specific, but it's a great exercise in string manipulation. We'll break it down step by step and look at a couple of clever ways to solve it. Okay, so here's the official problem description. Essentially, we're given a string that represents a really big number. Our job is to find what the problem calls a good integer inside this string. Let's break down what that actually means. So our main goal is to find something called a good integer. This isn't some complex math term. It's just a name the problem gives to a very specific type of substring. There are just two rules it has to follow. First, it has to be exactly 3 characters long. Second, all 3 of those characters have to be the exact same digit. This means we're hunting for patterns like 999 or 777. Even 000 counts, which is an important detail. Things that don't count would be 1, 2, 3, because the digits are different, or 5, 5 because it's too short. Even 4, 4, 4, 4 is no good. It has to be exactly 3 digits. The final piece of the puzzle is that we need to find the maximum good integer. So if our input string has a 777 and also a 333, we need to return 777 because it's the bigger number. And what if there are no good integers at all? In that case, the rules say we should just return an empty string. Simple enough. Let's walk through the first example. The input is this long string of numbers. As we look through it, we first spot 777. Great, that's a good integer. We'll keep it in mind as our current best. Then, we keep going and find 333. Okay, that's another one. Now we compare the ones we found. Is 777 bigger than 333? Yes, it is. So 777 is our final answer. Now for a couple of other cases. In the second example, we find 000. That's a valid good integer, and it's the only one, so that's our answer. This confirms that zeros are treated just like any other digit. In the third example, if you look through the string, you'll see there are no spots where 3 identical digits appear in a row. Since we found nothing, we return an empty string, just like the rule said. Okay, let's think about our first strategy. How many possible good integers can even exist? Well, there's 999, 888, and so on, all the way down to 000. That's it. There are only 10 possibilities in the entire universe. This gives us a really simple idea. What if we just check for each of these, one by one? First, we'll create a list containing all 10 of those good integers. The trick here is to put them in order from biggest to smallest. So we start with 999, then 888, and so on. You'll see why this order is so helpful in a second. Next, we just loop through our list of possibilities. We start with 999. We ask, is 999 anywhere inside the input string? If it is, we've found our answer. Because we ordered our list from largest to smallest, the very first one we find is guaranteed to be the maximum possible one. So we can just return it immediately, and we're done. If we don't find 999, we check for 888, and so on. And what happens if we go through our whole list, 999, 888, all the way to 000, and we don't find any of them in the input string? Well, if the loop completes, it means no good integer exists. So after the loop, we just return an empty string. It's a very clean and straightforward approach. Alright, let's look at another way to do this. Approach 2 is a bit more direct. Instead of having a pre-made list, we can just look at the input string itself. We can imagine a window that's 3 characters wide. We'll slide this window across the string from left to right, 1 character at a time. Here's the full code for this second approach. It looks pretty short, right? Let's walk through how it works. It all centers around a single loop and one variable to keep track of our best find. We start by creating a variable, which we'll call maxDigit, and we'll just set it to an empty character for now. This variable will remember the best digit we've seen so far, like 7 or 3, 5 ball. Then, we set up a loop to go through the string. Notice that the loop stops 2 characters before the end. That's because our window is 3 characters wide. If we start at the last character, there aren't 2 more characters after it to look at. Inside the loop, this is the core logic. For each position I, we check if the character at I, the character at I plus 1, and the character at I plus 2 are all equal. If they are, we've found a group of 3, so we then compare the digit we just found, which is the character at I, with our maxDigit variable. We take whichever is larger and store that back into maxDigit char. This way, maxDigit always holds the biggest single digit we've found in a good integer so far. Finally, after the loop has checked the entire string, our maxDigit variable holds the winning digit. Let's say it's 7. all we have to do is take that character 7 and repeat it 3 times to get our final answer, 777. And here's a really neat trick. If we never found a good integer, max digit will still be empty. In Python, multiplying an empty string by 3 just gives you an empty string back. So this one line of code handles both the success case and the edge case perfectly. So how do these two solutions compare in performance? Well, they're actually very similar. For the first approach, even though we only have 10 things to check, the in operation in Python has to scan the string, which takes time proportional to the length of the string. So we call that big O of n, half e. The space it uses is constant, or big O of 1, since that list of 10 numbers never changes size. The second approach also involves a single pass through the string, so its time complexity is also big O of n. And it uses almost no extra memory, so its space complexity is also big O of 1. Both are very efficient. So to wrap things up, what did we learn? First, always pay attention to the constraints of a problem. Realizing there were only 10 possible answers made our first approach super simple. Second, the sliding window technique is a classic for a reason. It's a powerful tool for analyzing parts of a string or array. And finally, for a problem like this, both solutions were clean and efficient. There's no single best answer, just different ways of thinking that get you to the same correct result. I hope that breakdown was helpful. If you found this useful, please hit the like button, subscribe for more Leetcode explanations, and feel free to drop any questions or other solutions in the comments below. And if you're feeling extra generous, you can always support the channel through the Boba Fund. Thanks for watching, keep up the great work, and I'll see you in the next video.